Well, by now you should have completed sections 2.2a and b in our lecture videos, and you should be partway through looking at section 2.2 in your textbook. I want to comment just a little bit about the numbering systems before we move on. When we get a long section like this, like section 2.2, I have to break the video up into pieces, and there is a subscripting to the section number that I add, A, B, C, and D, and so forth, simply to break that up. Apart from that, the lowercase letter subscripting, section 2.2 for the homework, section 2.2 for the video, and section 2.2 in the textbook are all the same. They're all aligned. But when it comes to these little lowercase letter subscripts, they aren't always aligned. So like homework 2.2a, which what we're going to do now, comes at the end of lecture 2.2b. So just don't pay any attention to that. Just do them in order, knowing that the section numbers, not the letters, but the section numbers are all consistent. Okay, so let's take a look at the new required code. Again, as usual, we have to comment the code line by line, the executable lines anyway. It also doesn't hurt to put a few lines of comments at the beginning of a section to say what you're trying to do. This is a very, very important part of programming for code that will be used by you later or by other people. Also, the indenting occurs for any loop or any conditional statement. So an if statement, if or else statements, or else if must all be indented along with the for loops and the while loops. They're the code that goes under them. Okay, with this case, we're just going to turn in our MATLAB. We're not too concerned about the pseudocode because the pseudocode is really carefully laid out in the book for you. There's no point in you redoing that. But I do want you to turn in your MATLAB code as well as the output of your MATLAB code. So keep that in mind when you run your code, save the output, and put that into either a PDF file or maybe just print it and scan it into a PDF file and send it to me. Okay, so let's take a look now at section 2.2a, or rather homework 2.2a. Now it says they're revised from the lecture video. The revisions here are really just small wording changes that I think add clarity and a change in the point scheme. Something I do want to mention is, in particular in this section, the homework is very sequential. Now that means you can't do homework 2.2a without having successfully done 2.1. So make sure that code is debugged. If you still have questions on 2.1, contact me, because you can't do the rest of it without having 2.1 work successfully. And then 2.2a is going to be a basis for doing 2.2b, and 2.2b will be the basis for doing 2.2c. Now 2.2d is a little bit of a different animal, but at least all the way up to 2.2c, you're going to need to be sure that you've got each step successfully done. Okay, let's go back and review the homework with this slightly revised wording. First thing to do is go to 2.1, literally make a copy of it so that you don't change 2.1 and you only change the copy. Call this copy 2.2a. That will be the name of this homework assignment, also the MATLAB file that goes with it. The only change you need to do as problem 1 is load the Excel file A2 rather than A. So you should have received by now 3 files, A, A2, and A3. This homework uses A2 only. It's a little bigger data set. It's a 10-dimensional system that we're going to run. And once you've made that change, just run it. And part 1b says run your code and demonstrate that the program fails. Okay, so we're saying, why does that fail? We thought we had succeeded in creating a perfectly good homework 2.1, and the first thing I do when I change data sets, it fails. So we'll need to talk about that. And really the answer is in section 2.2 that we often now call, and we will start calling 2.1, the naive row reduction approach, because it really assumes the data set's set up just the way you want it, and that's not always the case. So that's part 1 worth 5 points. Then we will do part 2, Okay, so we've called this thing homework 222A. By the way, I'm using underscores rather than points there because it confuses MATLAB if you use anything other than an underscore for a special character. So that's a nice safe name. Also, don't use spaces in your name either. That'll really confuse it, and it gives a very lousy diagnostic when that happens. So there's a name that'll work. And now you need to employ in 2.2a this simple partial pivoting per the procedure that's well documented in 2.2. Now, if you've read ahead within 2.2 a bit, you'll see that something's coming called row scaling, and we're not going to do that. We're only going to use column-oriented manipulations to determine how we choose our pivot row. Remember, the pivot row is that row that you're going to treat as the kind of like the upper left-hand corner of the section that you're working on. And just to be really specific about that, we're just going to go down column 1 and we're going to look for the maximum value, and maximum meaning the maximum absolute value, and use that as a basis to determine which row is going to exchange with row 1. And then when we're done with that column, we'll move to the next one and so forth. I'll spend a little more time on that in the hints portion. Okay, we will swap applicable rows by the choice we made in part A, and then you solve the system. Now, solving the system is pretty easy because you already did it in homework 2.1, and you don't need to make any changes to the logic of 2.1 in order to solve the system. So really, C is done once you've done A and B, if you haven't made a mistake in A and B. By the way, A and B happen as you go. It's not like you do a preliminary step and change your A matrix all around. You do it row by row as you're doing the row reduction. Okay, so that will solve the system for you. And the flops shouldn't change either, because I'm not asking you to count row exchanges as part of your flops. So you've really got D done. And then the only new thing there is to do the residual vector, which again, go back to your text and look that up. Don't use the MATLAB function that does norms. It's a perfectly good one, but you won't know how it's working. So I want you to code yourself the norm function. It's a very easy, very short set of code to do. So make sure that you have sent me your output for the A matrix, for the B vector, for the solution vector X, and this norm. So literally print it out and then print it to a piece of paper and scan it, or print it to a PDF file, or however you want to do it. But make that part of your homework submission. So the only hints really we need to say now is, again, reminding you to take a copy of homework 2.1 and call it something else like 2.2a, and load in A2 and observe you get an error and just print it out. That takes care of parts 1A and 1B. So the only thing that's really somewhat involved is problem 2. And you need to figure out which row exchange you're going to do. I often call that row swapping. I think the book calls it row exchanges. And the way you do that is start with the upper left-hand corner. So you're in position 1-1, and look down column 1 and find out which row corresponds to the largest absolute value in column 1. So if it turns out, if when you look at every value in column 1, that row 3 produces the largest value in column 1, then that becomes your clue that that's the row you're going to exchange. What you're really saying is you wish row 3 had been in row 1 to begin with, and row 1 had been in row 3. So you just want to simply take everything out of row 3 and put it in row 1, take everything out of row 1 and put it in row 3. One trick is you're not allowed to create new vectors. You're not allowed to create new matrices to do that. So you're going to lose points if you go, oh, I'm going to create a brand new matrix called, Q, and I'm just going to copy in what I want into Q the way I want it. That doesn't work. That's wasteful, and you'll lose points for that. Instead, you need to go cross the row that you're trying to exchange, and you need to change element by element between row 1 and this exchange row, which we were imagining to be row 3. Now that's pretty easy to use if you use a single temporary variable. That you can do. And you can simply take the value, let's say again in row 3 in column 1, store it in a temporary variable, let's call it t, and then go to row. Okay, so you can simply do that by taking a temporary variable, let's call it t, and store the value that's in position 1, 1. Okay, so that's now called t. Now go to your third row, again in this example, pull the value out of column 1, row 3, and stuff it into row 1, column 1. Okay, so you're clobbering that value. Fortunately, you save that value in this temporary variable t. So take the value that's in t and put it down into row 3 in column 1. And then you've succeeded in exchanging the first elements between row 1 and row 3. Now you've got to do the same thing for, again, row 1 and row 3, but column 2, and exchange those exactly in the same way. And also, again, for column 3. So you go through until you've run out of elements in those 2 rows, and that will have done the row exchange. So that's what those 3 bullets are trying to tell you under point 2, to just do it element by element, and then you'll have done the exchange. Now you can imagine that that's the way the matrix was to begin with, and you can continue with your row reduction for that particular column. We're all in column 1. That will give you zeros in rows 2 through the bottom, row 10, with this new row 1 established. Hey, we're still doing elementary row operations. We're just making use of row exchanges. Now you need to move to the position 2, 2, and that becomes your new pivot location. And we'll do the same thing the way we ordinarily do row reduction. So this time you're looking for the maximum value in absolute value in column 2, but only starting in row 2 because we have moved ourselves down 1 notch on the diagonal in doing this row reduction. So do the same thing, exactly the same thing you did before, just pretending row 2 is row 1. When you're done with that, move to pivot position 3, 3, and again, continue with the process. So you're allowing homework 2.1 to drive the logic, but just swapping rows as you need them as you go down this row reduction process. Okay, so I'm hoping that helps to get that going. When we do a solution, there will be no solution video for this one. I will literally send you out a PDF file of code that works and is consistent with the book after the deadline for the solution is over. So good luck, take care, see you next time.